Hello, good afternoon. So today will be a rather quick video because this is just me sharing my experience of using Kilo Code to generate an algorithm that I've never used before, an algorithm that I've never studied before. So let's see how it generates a code and whether I can trust the result or not. So as per README, I want to generate Monte Carlo research implementation. In this attempt, I'm going to try two models. The first one is Minimax 2.5 to generate the logic and Kimi 2.5 to generate RustDoc and code comments. Later we will see the result for each. Now, to use Kilo Code, especially for Rust projects, I need to set up a safeguard first. I do not want the agent to claim that its work has done, even though that it hasn't been done yet. So here is the rule. The rule is regarding the code validation. So I said, hi Kilo Code Agent, whatever model you're using, make sure you validate the code you generated. And I describe how the agent needs to validate the code. First of all, Pixie run format. This is just formatting the code. This comment corresponds to the comment found in Pixie TOML. So in Pixie project, you can actually use Rust. You don't have to use Python. And because of that, I set up all of my tasks here. And then I told Kilo Code to run this command, then run the linter, fix the linter for any linter error that might appear, and then run it again, and then run all of the unit tests. So that's the safeguard that I put. I hope that the agent follows. Now, what will be the first prompt? The first prompt is this: generate Monte Carlo research following the pseudocode and implementation given here. So this is the link. This link will lead us to this amazing resource from University of Queensland, Monte Carlo research. So there's an explanation about the offline planning and online planning for Markov decision processes. And then you have the illustration of MCTS, which is using expectimax trees. Well, you don't need to know this. You will learn this as you go along. And then these are the fundamental features. And then the framework. What should MCTS do? MCTS should select the child. Select a single node that is not fully expanded, and then expand, and then simulate. Simulate means that you're trying to play the game, or you're trying to simulate moving in the environment, and then you backpropagate the result. So similar to machine learning, basically, because you have the backpropagate. And there's an explanation of each step: selection, expansion, simulation, and backpropagation. And then the algorithm or the pseudocode is also provided. So basically in MCTS, we need to store this data in each node, a set of children nodes, a pointer to its parent nodes, and the number of times it has been visited. Next, we are going to use this algorithm for the Monte Carlo research, and then the algorithm to select, to expand, to backpropagate, to simulate, and then to backpropagate. And then an example is also given here. I'm not sure if the free models that I've mentioned can read from images, or even if it can read from this website at all. But yeah, I I basically give the instructions to look from this website and implement the pseudocode. There's also exchange selection and upper confidence trees, which I believe is also implemented, but later we'll see. And there's also an implementation for the nodes and the tree itself, the MCTS. And the node is extended to single agent nodes because this is single agent. This is the logic. And then there's a grid world visualization. Note that the final result will be, sorry, this is not the final result. This is the initial policy, I believe. The extracted policy is not very good. And then there's also GIF, which animates the improvement of the policy. There's also a section about function approximation. I'm not sure if this is used. Oh, because this is used for AlphaZero. So naturally it's not used here because function approximation in Q-learning means we have to implement deep Q network. Okay, and the rest is the comparison between value iteration versus MCTS. This is not linked to the implementation, but just so you know. And then there's also a section about combining MCTS and TD learning, which results in AlphaZero and further reading. So that's the reference for the agent. Now, how does the agent do? Okay, let me show you the prompt history. Because I renamed the folder yesterday, so I need to select all workspace. Okay, as I said to you, this is the prompt that I'm using. Oh, sorry, I've not finished explaining the prompt. In short, you are here to implement the Expectimax tree, both the node and the tree structure. Because if I do not explicitly say both of these, I'm afraid that the agent might not generate both. And then the search algorithm itself, of course. And then if you look at the website, this one, you will see that there's a goal state effectively, and there's a penalty state. And this one is blocked, so it will not give you penalty, but you cannot access this cell. You will be bounced back, basically. So the goal is to achieve row 0, column 3 as the reward of 1. And then the cell below, row 1, column 3 is the reward of negative or penalty. And then I also need to tell the agent about this. Cell 1.1 cannot be visited by the agent. If the agent tries to go to that cell, the agent will be blocked and goes back to the original square. And there are 4 possible actions. I don't think the coordinate system is necessary, but better to be explicit, right? Because I do not know the capabilities of the kilocode coding agents. And then just for consistency, for all implementations that require randomness, set the seed to this number. So this is actually how do I say, Unix timestamp. But this one you can set to any number that you want. This is just to make sure that the code run is consistent for all of the runs you did, because sometimes the seed can affect the performance, so it's better for me to just set this to be consistent. Okay, so this is the prompt. The agent has a set of checklists that it will follow. Analyze the requirements, create grid world environment with rewards and blocked cell, implement the tree node structure and the tree structure itself, implement the search, and etc. So kilocode generate these two, it did not generate these 2 files, but it edit these 2 files. Although I forget what the edit was. And then create grid world environment. So far so good, no problem. But yesterday when I tried this, the process took a little bit longer because yesterday I was at my university's library and the internet is slow as hell. So yeah, the process went for quite a while. It formatted and then it ran the linter. There are some problems, and I think the Kilo agent said, "Let me try building and testing directly since the warnings are minor and the code compiles." Then running the unit test again. I think same error, and for some reason the Kilo code assume I don't know whether this is an actual bug or not. I mean, like ignoring that code is a bug, but I'm not sure whether Rust compiler has this this bug because I've never seen this in Rust before. Like the Rust compiler usually knows perfectly if there's a dead code, it will give us the warning. So I don't know why Kilo code said this, or rather the model that I'm using. Oh, by the way, this one I'm using Minimax. Again, warning, and then and because of this false assumption, I think Kilocode directly build the release version and then run the executable from there, even though it does not need to. And I think there's also a problem where Kilocode try to run the program, but there is an infinite loop which makes the process longer. So I had to manually close or cancel the execution. The program is getting killed, likely to do an infinite loop. The problem with the coding agent is that if it generates a code with infinite loop, it does not know because it keeps waiting. So it comes down to you as the programmer to decide whether the program execution takes too long or not. If you feel like it's too long, you close it or you kill the process. But once you kill the process, Killcode can assume that there's an infinite loop or at least there's a performance issue. And I think here Killcode tried to run again, but still it's getting killed. Let me add some safety limits and debug the issue. And I think there's a funny change. There's a syntax error in the file. Let me fix it. But after the program avoids the infinite loop, I think for panic, Kilocode now can detect the issue, trying to sample actions when there are no valid actions like terminal state. And therefore, Kilocode can adjust the code as needed. And still again, panic. The tree size is only 10, which is suspicious. Let me debug to understand what's happening. And then there's also another bug. To be honest, when this bug occurred, I did not pay attention to the generated code. There's also type errors. Overall, I think it took me one hour to wait. Zero format. And again, I think because Kilocode assumes there's a compiler bug earlier, so I think it bypassed my guardrail. This one. Later you will see the result. So task completed. Do I trust it? Absolutely not. And by the way, if you're using Kilo Code, you can actually review the code. But I have another way to review this code. Basically, I reviewed the unit tests because the code itself is already hundreds of lines long, and the code does not have any explanation whatsoever. I asked Kilo Code to clean up all of the warnings, and then, yeah, this is the problem, right? I think this is a problem with coding agents. They're trying to find the fastest way to solve the issue, even though it might not be a best practice. Just spam this annotation for all of the warnings. So at the next prompt, I wait. Where's the next prompt? So that's why at the next prompt, I explicitly ask kilo code to clean up unused variables and unused parameters in the code. Do not use this annotation and remove existing annotations. I have to be very explicit. See, so there are still some leftovers, but I think this is close to the completion. And I think there's also another task. Let me check. Yes. So so after the first prompt, I tried by my own, and there's an error on the unit test. So I asked Kilocode to run the unit test again. This one I think is a rather short execution. So the conclusion from Kilocode is that the expectation is wrong. Expects state 1.1 when moving right from 1.0. So moving to the right means that the agent is here. The agent wants to move to the block cell. The unit test expects the agent to be able to access the cell. In reality, it's not, because in the prompt I already said that this cell cannot be visited by the agent. So yeah, you have to be careful with the generated unit tests as well. This is why I said earlier I check the unit test first. So when the agent tries to move right, it correctly stays at 1, 0. On the test expectation is wrong. But interestingly, on the second run, let me also run the formatting and limiting comments. In this task, the agent follows the consolidation rule that I previously set up. Alright, so what's next? Oops, sorry. Also, I tried generating Rust book, but this one is my fault because I do not need Rust book. What I need is the Rust doc. See, so that's why in the code you will not see any Rust book because I deleted all of the generated um because I deleted the docs folder. So that's why I said, can you add Rust doc to each struct, and each function should have documentation. And it generated a really verbose uh, comment. For example, like this one. Even because the instruction is wait the instruction. Each struct and each function should have documentation. Oh, I think this is the Rust doc. This one is not for the main file. This one is for the grid world. This one. and this one. Later, for these comments, there's also a separate task for it. I think I rephrase my prompt like this. Now I have all the codes. Provide this one is typo. But yeah, I want on the agent to provide detailed explanations for each file. The explanations should be put inside Rust as code comments. Skip explanation for Rustdoc or cargo deny, only explain logic. No need to explain the Rustdoc for the deny or allow macros. The reason why I did this is because the code runs at least based on the unit tests, but I don't understand the structure of the code. And this is the problem. Oh, by the way, if you are thinking why there are four files, this is because I split them up by myself. But yeah, apart from splitting up the logic into four files, I actually do not understand the logic behind it. So I asked the agent to generate a documentation for me. And there's also a funny moment. I accidentally truncated the file. Let me write the complete code. Thankfully, the agent can fix this. Otherwise, I don't know. Although I did use Git, so if I'm not happy, I can just revert everything. So yeah, this is the result. I will give you the link in the description, and I also stated my thoughts on the README file. I think it can get you to the 80% of the goal. And what's the rest 20%? The rest of the 20% is you need to validate themselves. So by running unit tests, checking unit tests, and checking the generated codes. In this case, I employ the help of Gemini to cross-check the code because I feel like Gemini is a much more reliable coder, including in Rust, compared to the free models, the Minimax 2.5 and the Kimi. And the second point, the answer is no, I do not understand. Before this, before I asked the agent to generate the explanation for the logic, I do not understand the flow. So I could not compare this with the reference, which is the book from University of Queensland, because here it's very structured, right? You have the overall algorithm, and then you also have the breakdown of each function. But when you look at the generated code, it's not very clear whether the agent follows this structure or not. So I say that the agent did not strictly follow the pseudocode. The agent followed the pseudocode at a certain level, but this is not your main loop. If you look at the code, your main loop will be unrecognizable from compared to this. So it turns out that this loop is actually inside the wait, where's the code? Run iteration. Now you see the selection, the expansion, simulation, and backpropagation. So it's deep inside the search file. So it's not something you see on on the main file. So it needs extra time to understand the code, and if needed, you also need to ask the agent to generate comments. And why is it called slop? The thing is, I do not know this algorithm, so I cannot fully verify whether this algorithm works or not. And like, what are the pitfalls? Maybe this algorithm, maybe this code will work on a specific scenario like this. Okay, because this is a grid world. I do not know whether this code will work for other dimensions of the grid or other use cases. I think for other use cases we need to do adjustments, and that's kind of expected. But what about different shapes of the grid world? That's something that we can test in the future. Okay, so I've provided you with the instructions on how to run this code, the build, the lint, the fix lint, and run the code. And you can also generate HTML from the Rust doc and then open it. So yeah, that's all from me. Thank you for following.